All right, so we do need to talk about what happens when we can't solve for one of the variables. So let's say, for example, we have an augmented matrix. It's in reduced echelon form. We end up getting zeros all here in this last row. Like, what do we do? So if we convert this back to a system, we see that we have an x1 minus 5x3 equals 1. We have an x2 plus x3 equals 4. And so x1 and 2 are in our pivot columns. Those are going to be what we call our basic variables. The other one is our free variable. And you can notice here, if you were to solve this for x1 and x2, they would both be in terms of x3. And we say that x3 is free, okay? Which means you can choose any value you want to for x3. It also means that x1 and x2 depend on x3. So if we let x3 be 0, then we would have a solution when x3 is 0, but that's not all the solutions, okay? We also might have when x3 is 1. So you have this here. So each different choice of x3 is a different set of solutions. And so those solutions are determined by x3. So let's use this as a guide for our example that we have right here. So you can look at this full matrix. It's a 3 by 6. If we do see that this is an augmented matrix, then we see that we actually have 5 x variables because I have 5 different rows here and then that augmented row. And I need to find a general solution to this linear system. I only have 3 rows, so I'm not going to be able to solve for all of the x variables here. You have to have the same number of rows and columns in the coefficient matrix in order for that to be possible. So I'm going to have some free variables here, and we're going to go ahead and do some row reduction and get this into as close of reduced row echelon form as possible. So let's go ahead and do that here by making all of the numbers above 1 on this right-hand side into zeros. I'm going to go ahead and write both of those. So the only thing I'm going to be keeping is that bottom row. And for this top one here, I need to take 2 times row 3, 2 times row 3, so 2 times 1, plus row 1, and put that into row 1. And then for my second set, and I'll just do this in a different color so you guys can see the difference here on the video, I can actually take row 3 and add row 2, and that will get rid of it there and put that into row 2. All right, so let's do this first row first. All right, every time I take something in row 3 and multiply it by the zeros, or multiply the zeros by the 2, whichever way you want to think about it, I'm still going to get 0. So everything in my first row is the same, except for that last one. So 2 times 1 plus -2 gives me 0. And our solution column, if you will. So 2 times row 3 is 14 plus -4 gives me 10 right here. All right, all of these row 3s, 0 plus 0, 0 plus 0, 0 plus 2, 0 plus -8. But then 1 plus -1, I get 0. 7 plus 3, I get 10. So I did 2 row operations in that one step. I like to color code and kind of save some space and get us to that spot. Okay. All right, I notice here that I can multiply by 1/2 to simplify just row 2. And that'll just clean things up a little bit. Remember, for reduced row echelon form, I do want to have the leading term be a 1. So that's super helpful for me here on row 2. And then really the only other thing I can do now is make all the numbers above that 1 a 0. So I need to take -2, row 2, add that to row 1, and put that into row 1. All right, row 3, nothing happens. Row 2, nothing happens. Can I have these zeros? And then I add that to row 1. Everything just stays the same as it is. Okay, -2, row 2 plus row 1 makes that a 0. That's why I did that. 8 plus -5 makes this a 3. And then -20 plus 10 makes this a -10. I actually have an error here. Sorry about that. You need to make sure you multiply by 1/2 on everything. If you were screaming at me through your video, sorry about that. Okay, so now -2 times 5 plus 10, this is actually 0. Right here. Okay, so let's think about what this means in terms of going back to our system. Okay, so what does that give me? That gives me that x1 plus 6x2 plus 3x4 must give me 0. It gives me that x3 minus x4, minus 4, excuse me, x4 must give me 10. And x5 must give me 7. So I have that one solution for x5. Yay. I have no idea what x4 is going to be, so I'm going to say x4 is free. I know that x3 is then 10 plus 4x4. I have no idea what x2 is, but I know x1 is dependent upon both x2 and x4. And so that's what my solution, my general solution, is going to look like if I have too many unknowns and not enough equations. Okay, too many unknowns and not enough equations. Well, what does this mean? We can call these parametric descriptions, okay, and where we can let x4 be equal to something, x2 be equal to something, and then we can figure out the rest of the system, okay? We call that a parameter, but it's not necessarily a variable anymore. It still is x2, still a variable, but we could plug in things and the system is then able to be solved based on that description. If we were to know, like, okay, if I know if x4 is 1, solve the rest of it, okay? We call those a parametric description. Here's another example of a parametric description. Again, I have 3 unknowns, x1, x2, x3, but only 2 equations. Not enough equations for the amount of unknowns. So I could set this up and say x1 is 21 minus 5x2. X3 is 4 minus x2. And x2 is free. So in this case, we say that x2, another way to say that is a parameter, and these two things are dependent upon it.